Hi everyone in CyberChem. So today we're going to take a look at measurement conversions, but instead of English conversions like we did in our last session, today we're going to look at metric measurement conversions. So let's go on and take a look at this. So the first thing is I want to remind everyone about all of our metric prefixes. Now you've probably seen this before, but we're going to use this chart as we go through some of our examples to identify which metric units are smaller and which are larger. So in the center here, if you notice, I'm going to start off, and this says base unit. So I'm going to start off here in the center with base unit, and our base unit for mass is gram, our base unit for volume is the liter, and our base unit for length is the meter. So these are the three basic units. So every unit that we have will have one of these, either G, L, or M as part of it, and then perhaps one of the prefixes. Doesn't have to, but it might. If we look to the left, these are all of the prefixes that are larger than the base unit, and they go up by tens. So we have deca, which is 10 times the base unit, hecto, which is 100 times the base unit, and kilo, which is 1,000 times larger than the base unit. So when we use this, we're going to say that 1,000 grams would fit in a kilogram, because a kilogram is 1,000 times larger than a gram. Going the opposite way, we have a tenth of the size, 1/100th of the size, and 1/1000th of the size. So I'm going to write that in two different ways so that you can get a sense of what I'm talking about here. So these units are all, or these prefixes are all smaller than the base unit. This is a tenth of the base unit, 1/100th of the base unit, and then finally all the way down here at 1/1000th of the base unit. We're going to use those as we convert to and from different base units. Okay, so if we take a look at some of the problems here, we're going to look at how to set these up, and they're going to be set up very similar to what we did in the English measurement conversions. So you're always going to start with what you're given. So in this case, I'm given 100 kilograms. Then we're going to do the same times and then a line, just like we were doing with our English units. And very similar to what we did with the English units, we're going to put the unit that we want to get rid of on the bottom, so it cancels out, and the unit that we want to end up with on top. So in this case, we want to get rid of kilograms. So kilograms is going to go on the bottom. We want to end up with grams, so grams will go on top. Finally, when we're setting up our units, what we want to do is pay attention to how many spaces we move and which units are larger. So I'm just going to copy from the previous slide our prefixes. So we had base unit, then on this side we had deci, centi, and milli, and then on the other side we had deca, hecto, and kilo. So if we're comparing grams and kilograms, notice grams is here in the center where the base unit is, and kilos all the way over here. So kilo is the larger unit. So we're going to put a 1 with the larger unit. And then what we need to do is figure out how many of the smaller units will fit into that larger unit. And the way that you do that is counting the number of spaces that it is away. So in this case, we have our base unit here, and we have kilo here. So we're going to go 1, 2, 3 spots to get to the base unit. So that's where my grams are. So if I move 3 spots, that means I need 3 zeros over here. Now, some of you are probably saying to yourself, I know an easier way to do this. I could just move the decimal point left or right because that's what we did in middle school or in elementary school. And I'm telling you that's wonderful, except remember, this is not our ultimate goal. we're never going to really be using metric units and converting them from one to another. Instead, what we're learning is a process that we're going to use when we're talking about moles and atoms and particles, things where you can't simply slide the decimal place to the left or to the right. So even though it looks like a little more painful of an activity to do it out in this form, please remember that our ultimate goal is different than your ultimate goal was back in middle school. So our ultimate goal is to learn this process so that we can use it going forward. Okay, remember that if a number is on top, you multiply. So we're going to put multiply by numbers on top. And if we had a number on the bottom that was different than 1, we would divide by numbers on the bottom. However, if you remember from our last class, I told you, you should never have to divide or multiply if the number is 1, because dividing by 1 and multiplying by 1 doesn't change your answer. So it's really a waste of time to try and put that into the calculator. So in this case, we have 100 kilograms times 1,000 grams per 1 kilogram. So we're going to get an answer of 100,000 grams. Kilograms drop out. Okay, let's take a look at problem number 2. So in this case, we have 200 centimeters. This, by the way, there's like a, look at that, it's like magic. My hand sort of disappears right in the spot. So we have 200 centimeters. I'm just going to write it up here so that you could see it. So we have 200 centimeters and we're going to meters. So centimeters go down here, meters go on top. Meters are in the base unit. So remember, this is grams, this is liters, this is meters. So all three of those are possibilities for there. So we have meters and we have centimeters. So the larger unit is the base unit in this case, so that's meters. So I'm going to put a 1 with the larger unit. Remember that we wrote that up here. And then since we're going from centimeters to meters, how many spots away is that? 1 spot, 2 spots away. So we have a 1 with 2 zeros. So going from centimeters to meters, we're going to take 200 centimeters. We're going to divide by 100. So we're going to get 2 meters as our answer here. Okay, so we went from a larger unit to a smaller unit. We went from a smaller unit to a larger unit. Now we're not going to use the base unit as one of our starting or ending points. Instead, we're going to go across the base unit. So in this case, we're going from hectograms, which is over here, to centigrams, which is down here. So we're going to start off with 2.36 hectograms. Hectograms, because we want to get rid of it, goes on the bottom. Centigrams go on top. Then we look. Hecto is all the way over here to the left. Centi is all the way kind of over here to the right. So the larger units are the ones on the left side. So hecto is larger than centi. So hecto is going to get the 1. Now to go from hecto to centi, we go 1 spot, 2 spots, 3 spots, 4 spots. So 1 with 4 zeros. 2.36 hectograms times 10,000 turns out to be 23,600 centigrams. And the unit of hectograms crosses out, just like up here, centimeters crosses out. So our final answer, 2.36 times 10,000, that's 23,600 centigrams. Okay, question number 4. Question number 4, we have 500 milligrams and we're going into kilograms. So we're going to start off with 500 milligrams times So now, milligrams is the unit we want to get rid of, so that's going to go on the bottom. Kilograms is the unit that we want to go to, that goes on top. Which of those two is larger, kilo or milli? So remember, the further left you are, the larger you are. So the larger unit gets a 1. Now, I've said this several times in the video already that the larger unit gets a 1, but there's always some students who try and oversimplify it and say, oh, the 1 always goes on top, or the 1 always goes on the bottom. That's not true. So if you notice here, the 1 is on top, here it's on the bottom, top, bottom. So you really have to identify which one is larger in order to know where to put that 1. Always put the 1 with whatever unit is larger. Now, in this case, I'm going from milligrams to kilograms. So milligrams to kilograms. So I move a total of 1, 2, 3, 4, 5, 6 spots. So I need a number that has 6 zeros in it. That's 1 million. So now I'm going to take 500 and divide it by 1 million. So I get 0.0005 kilograms. Questions on that? Let's take a look at the last one here. So in the last one, we have 15.9 decagrams, DA, that's right here. And we're going to decigrams, which is right here. So we're going to start off, we have 15.9 decagrams. We want to get rid of the unit of decagrams. So decagrams is going to go onto the bottom. So I'm just going to move this down to a smidgen. And decigrams is going to go on top. Decagrams is the larger unit, so that's going to get the 1. So we have 1 decagram. Then we're moving 1, 2 spots away to get to deci. So 1 with 2 zeros right here. So 15.9 times 100. It's 1,590 decigrams. And that is our final answer for number 5. So what I'm going to ask you to do is I would like you to try numbers 6 to 10 for homework. But what we're going to do first is we're going to go over together numbers 11, 12, and 13 because they're a little tricky. Not 11 so much, but 12 and 13. So we're going to skip ahead. And there'll be another video where I go over the answers to 6 to 10. Okay, we are back. Okay, we're back to take a look at numbers 11, 12, and 13. So number 11 is another straightforward problem. So we have 1.2 liters. We're going from liters to milliliters. So liters goes on the bottom, so it cancels out. Milliliters goes on top. Second part, what you want to do is identify which of those is larger. So liters is here in the center as a base unit, no prefix. Milliliters is down here. So liters is the larger one. To go from liters to milliliters, you move 1, 2, 3 spaces. So we have a 1 with 3 zeros. And then finally, if it's on top, you multiply. If it's on the bottom, you divide. So we wind up with an answer of 1,200 milliliters. Number 12 is where it gets tricky. When you have a unit that is cubed, keep in mind what a cubic unit means. So centimeters cubed is centimeters times centimeters times centimeters. So when I'm doing number 12, I have 358. I'm not even going to write centimeters cubed. I'm going to write centimeters times centimeters times centimeters. So I'm going to meters cubed in this problem. So I'm going to say, okay, centimeters goes on the bottom, meters goes on top. Here's meters, it's under base unit. Centimeters is down here. So meters is the larger unit, so that's going to get the 1. Centimeters is 1, 2 spots away, so that's going to get a 1 with 2 zeros. But here's the catch. When I divide by 100, which is what I would do here, that only crosses out 1 of my centimeters. So when you have a unit like this, which is cubic, you have to set up that conversion so that the conversion is also cubic. So in order to cancel out a cubic unit, you have to essentially do that conversion 3 times. Centimeters, centimeters. Notice when I do that 3 times, I also end up with a cubic unit. Meters times meters times meters is cubic meters. And then finally, 358 divided by 100, divided by 100, divided by 100, and that's actually how I would type it into my calculator. So 358 divided by 100, divided by 100, divided by 100, turns out to be 0.000358 meters cubed. And finally, for the last problem here, if we have something that is in milliliters, and we're going to see this again when we do our density lab next week in cyber chemistry. So if you have a volume that is in milliliters and you have a cubic unit, think about a little cube that looks like this. So if we have a cube here, and that cube has a measurement of 1 centimeter times 1 centimeter times 1 centimeter, so length, width, and height. If I have a cubic centimeter, it turns out that 1 cubic centimeter equals 1 milliliter. That's pretty much the easiest conversion that you're going to see on this homework. So when you go through it over here, 548.6 milliliters, you're going to get 1 cubic centimeter is equal to 1 milliliter. Milliliters go on the bottom, so they cancel. So that number will be exactly the same, 548.6 cubic centimeters. Some of you might be asking, why do we even bother going and having 2 different units then that are equal to each other? And the reason is that it depends on how your measurement is being taken. So on the density lab that we're doing next week, you're going to see that we're able to get the volume of some objects by water displacement. So we'll measure the volume of water in milliliters to begin with. We'll measure the final volume in milliliters with the object in the graduated cylinder. And the difference between those 2 volumes will be a volume in milliliters. Perfect. However, sometimes the objects float, so we can't get the volume by water displacement. So in those cases, we'll have to take the height of the cylinder, we'll have to take the diameter of the cylinder, and we're going to use the equation volume equals pi r squared h in order to get the volume. And in those cases, we're using centimeters as our length, width, and height, or as our height and radius. So in those cases, we end up getting centimeters cubed as a unit instead of milliliters. All right, hopefully everyone is kind of with me here. And again, for homework, I would like you to try numbers 6 through 10. And please remember to submit that on Schoology. Thanks very much, everyone.